All right, this is question number 1 off the 2018 AB exam. In this question, you're told that people are entering a line for an escalator at a rate modeled by this piecewise. So they're entering it at this rate between 0 and 300 seconds, and then they just stop entering it, okay? It tells you that they exit at a constant rate of 0.7 person per second, and that there's 220 people at time 0. Part A asks how many people enter the line for the escalator during the interval from 0 to 300. So this is the rate that they're getting in line. So if you integrate the rate they're getting in line, you get how many people entered the line. Part B, during the time interval 0 to 300, there are always people in line for the escalator. How many people are in line at time 300? Okay, so we have what you started with, plus how many people got in line, minus how many people got on the escalator, so got out of line. All right, so 20 plus, we already know that's 270. And then you can just button push on this one right here because it's a calculator question and you get 80 people. Part C, for the time is greater than 300, what is the first time t that there are no people in line for the escalator? All right, so if they're exiting the line at 0.7 person per second and there's 80 people left in line at time 300, well then 0.7 times however long it takes to get to 80 people, all right? Some pretty basic arithmetic gets you to here. 114.286, and then remember, this is how many additional seconds it took, or how many seconds it took after 300 seconds. So you have to add that number to 300, giving you your final answer right there, 414.286 seconds. And then in part D, between 0 and 300, at what time is the number of people in line a minimum to the nearest whole number? And then find the number of people in line at this time, justify. Okay, so I'm kind of going back to this equation up here, all right? Because this really tells me the number of people in line. And if I replace these 300s with t's, then that equation would be good for the number of people at any time. So that's what I've done right here. The people at any time is equal to 20 plus and just replaced with t's. I use a different variable, whatever. Okay, and then you want mins and maxes. Well, they occur when the derivative is equal to 0. So the derivative of people, that's like a people prime, is equal to, well, he's gone, plug in the upper limit, and multiply by the derivative of the upper limit. So that's just like r of t times 1. And then that guy right there, well, you can't really plug a t in anywhere, but that integration sign still cancels off, right? You're still deriving it. So that leaves you to here. Okay, this is a calculator question. So you'd graph this. All right, and then see where it crossed the x-axis. It happens here and here. Okay, so that's where those time values are coming from. And then you're going to plug those time values back into your integration up here to get those outputs. And so then you're comparing the endpoints. And when the derivative is equal to 0, that's clearly the smallest output, and it rounds to 4 people as it asked for in the question.